Hi guys, welcome back to the channel. Today I'll show you how you can build a tool using LangChain to ask any questions to a YouTube video. The YouTube video we're going to take a look at is the one over here. It's a video about DeepSeek. So let's look at the code. There you go. So let me go over the code at first, and then we're going to run through a couple of examples to show you how it works. Okay, so the first thing you want to do is define the YouTube URL, and then you use a data loader from LangChain called YouTube loader and pass it the YouTube URL. And you can also pass it this flag called add video info. What it does is in the response, it's going to bring back the information about the video, like the title, thumbnail, and other metadata alongside the full transcript. So you're using this loader to get the full transcript of the YouTube video. And later on, you're going to use the transcript and your question, feed it to the LLM model, and then get your answer. So in our case, we don't need the name or other metadata. We just need the transcript. That's why we're setting this Boolean to false. Okay, so this should give you the transcript. And now you want to iterate through the transcript. So you load the transcript chunk by chunk, and for every chunk, you create a document. So that's happening here. For every chunk, you create a document, and you build up this documents array. At the end of this for loop, you will have a documents array where each element is a document, and each document is a segment from the video. Once this is done, you just call your function called getAnswerFromLLM, pass it the documents and your question, and then you're going to get the answer. So we're going to look at the example with these two questions, and then we're going to do a deep dive into this function called getAnswerFromLLM to show you what's happening behind the scene. Okay, so let's run through two examples. The first example is we're going to ask the model, how does DeepSeek compare to OpenAI's model? So let's quickly run it here. It's going to take a minute or two because, as you know, the video is around 20 minutes. So it might take a little while to parse the transcript, turn it into a list of document, and then ask the question to the model. Okay, so it didn't take that much longer. So we have the answer here. It's a pretty long answer, but as you know, you can always tell it to give you the answer in under 100 word, 200 word, whatever verbosity you're comfortable with. So yeah, here's the answer. I cross-checked it against the content of the video. It's very accurate. So let's look at the next example. So we're gonna just ask the model about the cost. Let's run it again. So typically you want to store the documents indefinitely so that every time you run the tool, you don't have to go ahead and parse it again. But we're going to do that as part of a different video. So over here, you can see the answer. It says that DeepSeek's costs are significantly lower compared to OpenAI. And then it goes on to say that OpenAI's model takes around 100 million to up to a billion to train, whereas the one that was just released by DeepSeek costs you only like 5 million, which is what, like 95% price difference almost, which is absolutely insane. Okay, so hopefully that gives you an example about how you can ask any question to a YouTube video as long as you have a transcript for that video. There's another approach where if you don't have a transcript, you can turn the video into an audio, turn the audio into a list of documents, and then pass the documents to your model. That's the video that's going to be coming up, I think, in 2 to 3 days. Now let's take a look at this function here called getAnswerFromLLM. So what this function does is it prints out the question, and then this is the key function, get k relevant documents. So let's look at the function. So what the function here does is it takes the list of documents, and then for every document, it creates an embedding. Embedding is just, think of it like a vector with like a bunch of numbers. So for every document, it's going to create a vector or embedding, and then store it in a database. In our case, we're using the in-memory vector store, which is a database that you can store your embeddings in. Now, after this line of code, in that database, you're gonna have every document stored with its embedding. Now, in the next line where you do the similarity search, what you're asking the database to do is take my question. So the question I have, take my question, create an embedding of the question, and then compare it with all the documents that's there in the database to extract the top 3 documents that will most likely have the answer to my question. The top X is configurable. So in my case, I'm passing it k equals to 3 so that the vector DB can give me 3 most similar results, but you can configure it to whatever you want it to be. And then we're just returning the documents. So the result of this function is going to be a list of 3 documents that are the most likely to have the answer to my question. Now, at this stage, we have those documents and my question. And all I'm doing is from the documents, I'm creating a big string. So this string will have all the text from those documents. And then I'm passing to the model, which I'm doing over here, a list of messages. And the messages that I pass to the model will be the 3 documents. So you can see that I'm prefixing it by saying that use the following context to answer my question. So I'm telling the LLM that, hey, here's all the information that can help you provide an answer. Take this, take my question, and then give me a concise answer. Once you do that, you get the answer that's coming back from the LLM. So hopefully that was helpful. If you have any questions, just drop them in the comments and I'll try to get to them as soon as I can. As I said before, the next video will be about asking questions to a YouTube video or about a YouTube video. But instead of using the transcript, we're going to use the audio, which is a little more complex, but the fundamentals are pretty similar. Okay, so I think I'll end it there. Any questions you have, leave them in the comments below. And I will see you folks in the next one. Take care. Bye-bye.